Hello everyone. Today's topic is frequency distribution. This is your chapter number 15. In this chapter, first we'll discuss about some terms related to this chapter. Then we'll solve some question. So, what is data? Data means a collection of facts. Data means collection of facts in numerical figures. Okay, data means collection of facts in numerical figures. For example, the sale of shoes of various sizes at 8s off on a particular day is given below. These are the shoe size. Okay, 7, 8, 5, 4 and so on. Okay, so this is data. This is collection of facts in numerical figures. Okay, so in this data, in 9 is the maximum value and 4 is the minimum value. Okay, in this data, in this collection of facts, maximum value is 9 and minimum value is 4. Okay, so range of this data will be the difference between maximum value and minimum value. Okay, so 9 minus 4 equal to 5. This is the range of this data. Okay, then presentation of data. If we put the data in condensed form, for example, if we represent the data in a tabular form, that will be that is known as the presentation of data. Okay, then frequency. Frequency means what? The number of times often observation occurs. That is known as frequency. So let's find out the frequency of 4. Okay, so the frequency of 4 is 2. Frequency of 4 is 2. Okay, the observation 4 occurs in this data 2 times. So frequency of 4 is 2. Clear? Then frequency distribution. Frequency distribution means the tabular arrangement of the data showing the frequency of each observation. Okay, when you represent the frequency in a tabular form, that is known as frequency distribution. Clear? Okay, so this is the example. The sale of shoes of various sizes of on a particular day is given. Okay, so this is the data. Okay, this data is known as what? Raw data, because the data is in original form. Okay, so that is known as raw data, or we can say ungrouped data. Ungrouped data. Okay, now look at the frequency table. Okay, so in this column, write down the size of the shoe. Okay, so 4, 5, 6 and so on. These are the size of the shoes. Okay, then tally marks. Tally mark means, for example, 4. Okay, so while go through the data, when 4 occurs, you can put a mark. Okay, you can put a bar, that is known as tally marks. Okay, tally marks used for error free. Okay, so the number 4 occurs in this data two times. Okay, so tally marks of 4 will be 2 line or 2 bar. Okay, then write down frequency here. Clear? Next, 5. Okay, so let us find out the observation 5. So here is the 5. Okay, now put the mark here. Then again we have 5. Then second line or second bar. Then we have 5 here. So this is the third bar. Then here we have 5, fourth, then at last we have another 5, that is 5. Instead of the showing the number 5 in this form, what we'll do, we represent 5 in this manner. Okay, so that will indicates the number 5. Okay, so frequency of 5 is 5. Okay, then frequency of 6 is 4, and so on. Okay, so that is known as frequency distribution table. Okay, in this column write down the size of the write down the size of the shoe. Then in the second column write down tally marks. Then in the third column write down frequency. Okay, then at last write down the sum of the frequency, that is 28. Clear? Okay, next, group data. Group data means when the data is very large. Okay, so here the shoes of 28. Okay, what if the shoes are 28,000? Okay, in that case we'll make groups of suitable size. Okay, that is known as grouped frequency distribution table. For example, the given below are the marks obtained by 40 students in an examination. Okay, so these are the marks of 40 students, 3, 5, 48 and so on. As you can see, this data is very large. Okay, so we'll condense this data. Okay, so in group data there is a term that is class interval. Class interval means group data is, I told you, when the data is very large, we'll make groups. Okay, we'll make groups of suitable size, right? And that group is known as class interval. Okay, for example, 1 to 10, 11 to 20, 21 to 30, these are the examples of class interval. Okay, in this class interval, as you can see, for this let's take this class interval 1 to 10. Okay, this 1 and 10 is known as what? Class limit. Class limits. Okay, and the left side of this class, that means 1 is known as lower limit. 1 is known as lower limit and 10 is known as upper limit. 1 is known as lower limit and 10 is known as upper limit. Like that, in this class interval, 11 is the lower limit and 20 is the upper limit. Clear? Then type of frequency distribution. So the first type is exclusive form. Exclusive form. Okay, exclusive form means in this frequency distribution will include the lower limit of an interval but will exclude the upper limit. Will include lower limit but will exclude the upper limit. Okay, then inclusive. Okay, so for example, for exclusive form, the class intervals will be like 1 to 10, 10 to 20, 20 to 20 to 30. These are the examples of exclusive form. Okay, so in this class we'll include the numbers lies between 1 to 10, and we will include the number 1 also, but will not include the number 10. Okay, that is exclusive form. Then the another form of a group data frequency grouped frequency distribution, that is inclusive form. Inclusive form. Okay, so inclusive form will include both upper limit and lower limit. Okay, in inclusive form will include both upper limit and the lower limit. For example, for inclusive form, the class intervals will be like 1 to 10, 11 to 20, 21 to 30. Okay, so in this class interval will include the number lies between 1 to 10, and will include the numbers 1 and 10 also. Clear? In exclusive form will include lower limit but will not include upper limit. Okay, in exclusive form, the class intervals will be like 1 to 10, 10 to 20, 20 to 30. Okay, so in this class we'll include the number lies between 1 to 10, and will include 1 also, but will not include 10. Clear? But in inclusive form will include both upper limit and lower limit. That means, and the class intervals will be like 1 to 10, 11 to 20, 21 to 30. Okay, in this class we will include the number lies between 1 to 10, and will include both upper limit and lower limit. Clear? Okay, now let us see an example. Okay, so given below are the marks obtained by the 40 students in an examination: 3, 25, 48, 23, 70, and so on. So these are the marks of 40 students in an examination. Clear? Now we have to arrange the data in ascending order and present it as group data in discontinuous interval form. Discontinuous interval form means this is another name of inclusive form. Okay, discontinuous interval form, taking class interval like 1 to 10, 11 to 20, etc. And second one is continuous interval form. Continuous interval form means exclusive form. Okay, so continuous interval form means exclusive form, taking class interval 1 to 10, 10 to 20, etc. So first things, we have to arrange the data in ascending order. Okay, so this is the ascending order of the data: 3, 3, 5, 8, 9, 10, 11, and so on. Okay, then we have to represent the data in exclusive form and inclusive form. Okay, so first one is given discontinuous interval form. Discontinuous interval form means inclusive form. Okay, so make the table. Okay, so this is write down here marks, then class intervals. It is written in the question: class intervals, taking class intervals 1 to 10, 11 to 20, like that. Okay, so 1 to 10, 11 to 20, 21 to 30, 31 to 40, and 41 to 50. Okay, because the maximum value is 48. Okay, that's why the last class interval is 41 to 50. Then tally marks. Okay, in tally marks, okay, so this is inclusive form. Okay, in inclusive form we'll include both upper limit and lower limit, and the number lies between upper limit and lower limit. Okay, so we'll count the numbers lies between 1 to 10 and 1 and 10 also. Okay, so look at the data: 3, 3, 5, 8, 9, then 10. Okay, so we have 1, 2, 3, 4 and 5 and 6 numbers. Okay, so represent the tally marks first. So this is the bunch of 5. Then we have single bar, that is 5 plus 1, 6. Clear? Then here write down the frequency. Okay, then 11 to 20. Okay, so 11, 12, 13, 15, 17, 17, 17, 19, 19, 19, then 20. Okay, so the frequency is 11. Okay, so this is 5, then again 5 plus 5, 10, then 1, 11. Clear? Then continuous interval form, or you can say exclusive form. Okay, so in exclusive form the class intervals will be like 1 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 45, right? So in this class interval 1 to 10 we will include the numbers lies between 1 to 10, and we will include number 1 also, but we will not include 10. Clear? Now look at the data. Okay, so we will include the number between 1 to 10 and 1, but we will not include 10. Okay, so 3, 3, 5, 8, 9 will not include 10 because it is in exclusive form. Okay, in exclusive form we will not include upper limit. That's why frequency will be 5. Okay, so in this for this class interval the frequency is 5 and represent the tally marks. Clear? Then 10 to 20, for this interval we'll include the number which lies between 10 to 20, and we'll include 10 but will not include 20. Okay, now look at the data. Okay, so from here 10, 11, 12, 13, 15, 17, 17, 17, 19, 19 and 19 will not include 20 because that is upper limit. Okay, so the frequency will be 1, 2, 3, 4, 5, 6, 7, 8, 9, then 10, 11. Okay, so the frequency of this interval is 11. Sorry, not this one. This one. Frequency of this interval is 11. Clear? Next, class boundaries, or you can say true upper limit. True upper limit and true lower limit. Okay, so what is true upper limit and true lower limit? We have studied about upper limit and lower limit. Okay, so remember, for exclusive form, okay, for exclusive form, true upper limit and true lower limit will be same. Okay, that means the upper limit is upper limit is true upper limit, and true lower limit is lower limit. Okay, for example, in exclusive form there is a class interval that is 1 to 10. Okay, so 1 is lower limit and 10 is upper limit. Okay, for this interval the true upper limit is also 10, that is upper limit, and true lower limit is 1, that is lower limit. Clear? Okay, then inclusive form. In inclusive form, okay, the true upper limit will be sum of upper limit of a class, sum of upper limit of a class plus sum of lower limit of subsequent class. Sum of upper limit of a class plus plus lower limit of subsequent class divided by 2. For example, for this in a class, the true upper limit will be upper limit of this class, that means 10, plus lower limit of subsequent class, that is 11. 10 plus 1 or 10 plus 11 divided by 2, that is 10.5. So 10.5 will be the upper limit of this class and 10.5 will be lower limit of subsequent class. Clear? Like that, the upper limit of this interval will be upper limit of this class, that is 20, plus lower limit of subsequent class, that is 21, divided by 2. So 20 plus 21, that is 41 by 2 equal to 20.5. Okay, so upper limit of this class is 20.5, and sorry, true upper limit of this class is 20.5, and true lower limit of this class is 20.5. Clear? Then class size. Okay, class size means what? The difference between the true upper limit and true lower limit of a class is known as class size. Okay, so difference between true upper limit. Okay, so let's take this class, the difference between true upper limit and true lower limit. Okay, so this is the exclusive form. In exclusive form, true upper limit and true lower limit will be same. Okay, will be same as the what, our upper limit and lower limit. Okay, so here true upper limit is 20 and true lower limit is 10, and the difference between true upper limit and lower limit will be the class size, that is 10. Okay, then class mark of a class. So class mark of a class is, the formula is true upper limit plus true lower limit divided by true. Class mark of a class is what? True upper limit plus true lower limit divided by 2. Okay, so for this class, true upper limit is 20 plus true lower limit is 10 divided by 2. So 20 plus 10, 30 divided by 2, that is 15. So for this class, 15 is the class mark. Okay, so class mark of this class is 15 and class size is how much? 10. Okay, now for this class interval, the class mark will be 10 plus 30 divided by 2, that is 50 by 2, 25, and class size will be 30 minus 20, that is 10. Clear? Okay. And the difference between two successive class mark equal to class size. This is very, very important. Class size equal to how much? Class size means the difference between true upper limit and true lower limit, that is class size. Okay, and another formula is the difference between two successive class mark, for example 15 and 25. The difference between two successive class mark equal to the class size. That means 25 minus 15 equal to 10. As you can see, the class size is also 10. Okay. Clear? So class mark, the difference between class mark of two successive class, okay, two successive class mark equal to class size. Okay. Okay. So there is a question. The class marks of a frequency distribution are 7, 13, 19, 25, 31, 37 and 43. So class mark is given. Okay. Find the class size and all the class interval. Okay. So class size equal to what? Difference between two successive class mark. I have already told you. Okay. So difference between two successive class mark, for example 7 and 30. So difference between 7 and 30 is 6, that is class size. Okay. Let the lower limit of the first class, okay, lower limit of the first class be a, then the upper limit will be a plus 6. Clear? If the lower limit is a for the first class interval, then its upper limit will be a plus 6, that is a plus class size. Clear? Now a plus 6 by 2 equal to 7. That means a is the lower limit. Clear? A is the lower limit and a plus 6 is the upper limit. Okay. So lower limit plus upper limit divided by 2 equal to class mark. Remember the formula? Class mark equal to true upper limit plus true lower limit divided by 2. Okay. So this is a is upper lower limit and a plus 6 upper limit. Okay. So a plus 6 divided by 2 equal to 7. 7 is what? Class mark of the first interval. Clear? So 2a equal to 8 and a equal to 4. Okay. So first interval will be a and a plus 6. So 4 plus 4 and 4 plus 6 is 10. Clear? This is the first interval. Clear? Okay. Now the last interval, let the last interval of the lower limit of the last interval be of v, and its upper limit will be b plus 6, obviously, because 6 is the class size. Clear? And the class mark equal to lower limit plus upper limit divided by 2, true upper limit plus true lower limit divided by 2. So b plus 6 by 2 equal to 43, because 43 is the last class mark. Okay. So here we get b equal to 40. So last class interval will be b plus b, that is 40, and b plus 6, that is 40 plus 6, that is 46. That is the last class interval. Okay. Now the class interval will be, all class interval will be like 4 to 10, then 10 to 16, then 16 to 22, 22 to 28, 28 to 34, 34 to 40, and 40 to 46. Okay. Next, how do you form a class of a data? Okay. So this is a question. The water tax bills in rupees of 30 house in a locality are given below: 147, 167, 136, and so on. These are the water text field of 30 house. Okay. Now construct a frequency distribution table with class size 10. Okay. Okay, so here the minimum observation is 115 and the maximum observation is 212. Okay, so range will be the difference between maximum value and minimum value, that is 212 minus 115, that is 97. Clear up to this? And class size given, that is 10. Okay, so range of this data is 97 and class size is 10. Okay, so 97 divided by 10 equal to 9.7. So we should have 10 classes. Okay, so we should have 10 classes and each of size 10. Up to this clear? The range is 97 and class size is given, that is 10. So 97 divided by 10 equal to 9.7. So we need 10 classes of each size 10. And the classes will be, okay, so 115 is the minimum observation. Okay, so and the class size is 15. So if this is the lower limit of the first class, then its upper limit will be lower limit plus class size is 10. So 115 plus 10, that is 125. Clear? This is first interval 115 to 125. Then second interval will be second class interval will be 125 plus 10, that is 135, and so on. Clear? Now look at the table. So write down your bill. Okay, now in this column write down the class interval 115 to 125, 125 to 135, and so on. Clear? Now in second column write down tally marks. In third column write down frequency. Clear? So first class interval 115 to 125. Now let us find out the number lies between 115 to 125, including 115, excluding 125. Okay, so the numbers are 116, then 121, 115, then 118. Okay, so frequency of this interval is 1, 2, 3, and 4. Okay. Okay, in here put 4 bar, that is for tally marks. Okay, then moving to second interval, second class interval, that is 125 to 135. Will include the number lies between 125 to 135, including 125, excluding 135, including 125 and excluding 135. Okay, so the numbers are okay, 134 and 133. Okay, so frequency of this class is 2. Clear? So like that you have to find out the frequency of all this class interval. Okay, then at last the total frequency will be, the total frequency is 30. Clear? Next, rule to convert discontinuous or inclusive form to continuous, that is exclusive form. So if you need to convert an inclusive form to exclusive form, for that you need adjustment factor. Okay, so the formula is 1 by 2 into lower limit of one class minus upper limit of previous class. Okay, for example, the class interval like 1 to 10, then second interval is 11 to 20. Okay, so adjustment factor is 1 by 2 into lower limit of one class. For example, 11 is the lower limit of this class minus upper limit of previous class. Upper limit of previous class is 10. Okay, so 11 minus 10 divided by 2. Lower limit of one class minus upper limit of previous class divided by 2. So 11 minus 10 by 2, that is 1 by 2 equal to 0.5. Okay, so this is the adjustment factor. Okay, now you need to or subtract this adjustment factor from lower limit of the class, then add this adjustment factor to the upper limit of the class. Clear? Subtract the adjustment factor from the lower limit of a class and add adjustment factor to the upper limit of class. For example, this is the discontinuous form, okay, or inclusive form. So that is given, and we have to convert this frequency distribution from discontinuous to continuous form. Clear? That means inclusive to exclusive form. Okay, so class intervals marks is given and frequency is given. Okay, so first things you have to do, that is find out the adjustment factor. For example, 11 is the lower limit of a class and 10 is the upper limit of previous class. So the formula is 1 by 2 into lower limit of a class minus upper limit of previous class, that is 10. So 10 minus 11 minus 10, that is 1. So 1 by 2 is 0.5. Clear? Now subtract 0.4 or 0.5 from each lower limit and add 0.5 to each upper limit. Okay, so make a table, write down your marks and write down in bracket before adjustment and that is after adjustment. Okay, so in this column write down the class interval that is given in the question: 1 to 10, 11 to 20, then 21 to 30, 31 to 40. That is inclusive form. Okay, now its exclusive form will be subtract the the adjustment factor from the lower limit. So 1 minus 0.5, that is 0.5, then add 0.5, that is adjustment factor, to the upper limit, that means 10.5. okay, then its second class interval will be 10.5, that is 11 minus 0.5, and this is 20 plus 0.5, that is 20.5. Clear? Okay, now at last we'll discuss about cumulative frequency of a class interval. Okay, so cumulative frequency means sum of the frequency of all previous class. Sum of the frequency of all previous class, okay, and that particular class is called cumulative frequency. Okay, so cumulative frequency of a class interval is what? Sum of all frequencies of frequency of the previous class and that particular class also. Okay, so following are the age in year of 360 patients getting medical treatment in a hospital. Okay, that is given in the question: age in years 10 to 20, 20 to 30, 30 to 40, 40 to 45, and so on. Okay, and these are the number of patients. Clear? Then construct the cumulative frequency for the above data. Clear? Now make a table. So in this column write down the class interval, and class interval is given here: 10 to 20, 20 to 30, write down there 10 to 20, 20 to 30, 30 to 40, and so on. Okay, then in the second column write down the frequency. Okay, frequency is also given, that is number of patients: 90, 50, 60. Okay, so write down here 90, 50, 60, 80, 50, and 80. Okay, then another column, that is cumulative frequency. Cumulative frequency, as I told you, sum of the frequency of all previous class and that particular class. For example, we'll find out the cumulative frequency of this class interval. Okay, so sum of all previous class, sum of the frequency of all previous class. So 90 plus 50, 90 plus 50, 140. Okay, and that particular class, that is 60. So 140 plus 60, that is 200 cumulative frequency. Clear? Okay, now for this class interval 20 to 30, frequency is 50. Okay, sum of the that particular class plus sum of the frequency of all previous class. So previous class, so frequency of previous class is 90, so 50 plus 90 is 140, and the frequency of the cumulative frequency of first interval will be same as the frequency, that is 90. Okay, because there is no previous class. Clear? So today's homework is exercise 15. If you have any doubts, you can ask me. Thank you, students. Have a great day.